Hi everyone. Today we are going to discuss about limit in calculus, but one different rule I shall apply today. What is that? That is L'Hospital's rule. That is a well-known rule when a limit is in the form of 0 by 0. What is 0 by 0 form? Here in the expression you can see that limit x tends to 0 tan inverse px by sin qx. So if you place the actual value of x as 0, then sin qx becomes sin 0. Q into 0 is 0, that is 0. So keeping the actual value, putting the actual value in numerator and denominator both, first we have to evaluate if both the numerator and denominator are being evaluated as 0. Similarly, if I evaluate tan inverse px by placing x equal to 0, that means it is also tan inverse 0. Now we know tan inverse 0 is also 0. So the formula which is applied as L'Hospital's rule specifically tells us that if a particular limiting expression is of form 0 by 0, then the limit can be evaluated as limit x tends to 0 derivative of numerator divided by derivative of denominator. This is L'Hospital's rule's basic statement. When we apply the L'Hospital's rule, when we cannot evaluate a particular limit using the fundamental basic rules, that is the 5 or 6 formulas that we generally use. Now today I will show you why I will be using the L'Hospital's rule in this particular problem and how we are getting the derivatives and finally getting the final value. So the main problem statement is limit x tends to 0 tan inverse px by sin of qx, right? Now there is no such fundamental rule of inverse function. Rather, if I place directly the value of 0, the actual value of x equal to 0 in both numerator and denominator, then it evaluates to 0 by 0. That is an undefined function or undefined value. So for doing this, I am applying L'Hospital's rules. That means limit x tends to 0 ddx of tan inverse px divided by ddx of sin qx. What is tan inverse px's derivative? That is 1 by root over 1 plus p square px whole square, right? At the same time I have to do ddx of px, which is p, divided by ddx of sin qx is q cos qx. The whole evaluation will be done based on limit x tends to 0, right? Now this is a chain rule you can understand, because ddx of tan inverse x, we know that ddx of tan inverse x is 1 by 1 plus x square. So ddx of tan inverse px will be 1 by 1 plus px whole square. At the same time px I have to also derive with respect to x, which comes as p. Now if you understand that we have already got our desired template to find the actual value of this limit, what will be that? That is simply p by root over 1 plus p square x square, p by root over 1 plus p square x square into q cos qx. Whole expression will be based on the limit x equal to 0, x tends to 0. Now if you place x equal to 0, that is the actual value of x, then you can understand that cos qx will be cos 0, that is 1, right? So only remaining portion will be p divided by q. So my answer will be here the p by q by placing actual value of x equal to 0. So this is a template of using L'Hospital's rule, which basically states that if your limit expression is in the form 0 by 0, then that will be evaluated based on limit x tends to 0 ddx of numerator by ddx of denominator. That is why we have evaluated this particular expression. If you like this video, I will request everyone to view, subscribe and like my channel and give your comments as well. Thank you.